Hello and welcome. In this tutorial, we'll show you how to use the custom condition node in the motion planning system. It allows you to define node states based on conditions beyond placement, occupancy, or proximity values. Let's get started. First, we'll use a simple example to illustrate the node setup and later apply it to different real-world scenarios. In this scene, we have two characters and two sets of MD props for demonstration. Open the node graph editor, and we can see that in the Aaron group, he will randomly switch between the sit-on chair and the observe MD props. Enable the loop option in the start node if we want him to repeat this behavior continuously. As for Ariana, she will move according to Aaron's actions. Using a check Boolean node, she will switch between two position points depending on Aaron's state. Make sure her workflow is also set to loop. To set up Boolean variables in the node system, switch to the Variable tab on the right. Under the Boolean section, add a Boolean variable that we will use later. Rename this variable to sitting down. You can add additional Boolean variables as needed. Back in the node graph, we need to place a set Boolean node at specific points in the workflow to trigger the variable. Disconnect the top stream and search for the set Boolean node. Connect it before the sit-down MD prop node and set the Boolean variable to sitting down that we created earlier. Each time the workflow passes through this node, the variable state will change to the value we specify. In this case, enable the value option. Next, duplicate the set Boolean node and place it at the end of the stream after the stand-up node. This time, uncheck the value option to indicate that Aaron is no longer sitting. Repeat the same process for the observe MD prop stream. This time, change the variable to observing. The setup follows the same principle. For Ariana's workflow, place a check Boolean node at the beginning of the stream and set the Boolean variable you want to evaluate. In this example, set it to sitting down. This allows Ariana to detect Aaron's intention whenever he is about to sit down. If the Boolean returns true, she will move to the left position point. Otherwise, she will move to the right. After clicking Go MD, we can see that whenever Aaron walks toward the left to sit down, Ariana follows him to the left position point. She adjusts her position in sync with Aaron based on the Boolean value. We can also monitor the current Boolean states in the Variable tab at the top right of the node graph. Next, we will apply the same concept to three practical scenarios. Let's first look at the intended setup. In this MP set, we want the yellow workers to clear the shelves on the left whenever the red workers on the right begin moving products on the table. The second example resolves a potential conflict between the yellow workers when they attempt to move the same object at the same time. The third scenario works as follows. After the red workers place products on the table, the green worker will pick them up and move them to the shelves on the left. However, we also want the purple supervisor to log each inventory item whenever the green worker moves a product. This logging task should interrupt the supervisor's current activity every time, even if he is in the middle of operating a machine. Now let's start constructing the first scenario. We can see there is a 10-second idle period before the red workers begin their tasks. During this time, every worker should remain in an idle or resting state. Open the node graph editor and insert a set Boolean node immediately after the idle node for the red workers. In this setup, two rest nodes are connected to a single set Boolean node. By doing this, any character exiting the rest node will trigger the subsequent set Boolean node. If you want to track each character's state separately, you can use multiple nodes for different characters. Next, create a variable to represent this state. Open the Variables tab and add a Boolean variable named redWorkersStart. Then return to the set Boolean node, assign it to this newly created variable, and enable the checkbox. For the yellow workers, create a check Boolean node at the beginning of their workflow. Set the variable to redWorkersStart. If the condition returns true, they will begin clearing the shelves. If it returns false, create a character node and assign an idle action. select the character, and set up the desired idle motion. Repeat the same structure for the second yellow worker, then press Go MD. Now, whenever the red workers start moving, the yellow workers will immediately begin their tasks as well. In the second example, we can see that when there is only one product on the shelf and one worker is already moving toward it, the second worker may still attempt to take the same product. However, the product has already been assigned to the first worker, which creates a conflict. To resolve this, we can set up a Boolean variable to indicate that a worker is already on the way to retrieve the package. If this variable is active, the second worker will ignore the package and continue with the subsequent workflow in the graph. To set this up, notice that there is already a check placement point node used to determine whether there are items on the shelves. Now, we need to add another condition to check whether someone is already heading toward that item. First, create a set Boolean node and add a new variable that represents someone moving to pick up the object. Set the Boolean to the correct variable and enable the value checkbox. Also remember to add a node at the end to reset the state. For the second worker, add a check Boolean node and assign it to the variable we just created. If the value is false, meaning no one is currently retrieving the object, the worker will proceed to pick it up. If the value is true, meaning another worker is already handling it, the second worker will skip this action and continue to the next workflow downstream. During execution, we can observe the variable state changing from false to true, causing the second worker to immediately ignore the package on the shelf and move on to interact with other MD props instead. The third workflow requires the supervisor to verify the mover every time, even if he is currently operating an MD prop in another area. To avoid colliding with the red movers, he first checks whether both red workers have left the green area before moving the products. If the area is not clear, he will remain at the waiting point near the table. For more details on range-based condition setups, please check the tutorial linked in the description. In the original setup, the green worker moves products whenever there are items on the table, while the supervisor independently performs random inspections on the other side. Their workflows are not connected. To link these behaviors, we first set up Boolean nodes and variables before and after the move node for the green worker. The variable is called moving toward the table. This variable becomes true when the worker starts moving toward the table and switches back after the action is completed. So, like before, add a Boolean node to reset the state at the end. Next, configure the supervisor's workflow. Since the supervisor needs to interrupt whatever he is doing as soon as the green worker begins moving toward the table, the check Boolean node needs to be placed after the random MD prop subgraph node. When the green worker begins moving to the table, the supervisor will immediately take out the logging notebook to verify whether the inventory is correct. If the condition is not met, add a wait node that checks the Boolean state every 0.1 seconds and connect it back to the check Boolean node. With this setup, the previous subgraph node continues executing normally while the Boolean status is being checked. Once the state switches, the workflow will immediately execute the true output branch. Make sure the interruptible and loop options are enabled for this node structure, as well as for the outer loop. After pressing Go MD, the supervisor will continue his routine and stay in the random logging loop. When products appear on the table and the green worker begins walking toward it, the Boolean state changes. At that moment, the purple supervisor will immediately head to the table and verify the inventory together with the green worker. With this intuitive Boolean variable setup, you can easily control intricate interactions within the motion planning system in iClone. The workflow possibilities are virtually limitless, giving you powerful tools to build complex digital simulations. Thank you for watching, and see you in the next tutorial.